Okay, hello everyone. Welcome back to our FLL Robotics lessons. This is week 2 and day 2. And I'm Zeel Patel and team FTC 5795. So in this video we're going to talk about like coding and programming and like optimizations for programming with your robot. So the first thing we want to know is how to find an optimal route for programming missions. So what we want to do is to look for the shortest possible route in terms of distance to get to a designated area. In addition, you want to try and optimize your sensors if you have a chance in your mission, and we'll go over how you can use those sensors. Try to make the best attachment possible for the mission you are trying to complete. So those are the 3 steps that you want to find an optimal route for your programming mission. Then, so what types of sensors could you use in the mission? So there's 4 main ones, those being color sensors, touch sensors, ultrasonic sensor, and gyro sensor. But people also use infrared and some other sensors that come with it. And so the color sensor is probably the most widely used sensor that teams use. And you can use the color sensor to line follow or line detect. So on the entire map, you will have there'll be lines, there'll be black lines, and you could pretty much follow those if you have the correct line following code. Or what you could do is you could detect where you find that line and then do your next action after that. And then what you can use a touch sensor for. So touch sensors are most commonly known for starting a program. So pretty much at the beginning of your program, whenever you touch your button on the EV3 brick, you tend to move the robot by a little bit. So by having a touch sensor, it removes that type of like variability and like how much force you're putting onto starting the program through the EV3 brick. So it leads to like less like incorrection. And then you can also use a touch sensor for bumping off a wall. So when it bumps off a wall, when it gets fully pressed and you want to run into a wall like all the way straight down the whole mat, you can do so, and then you can perform your action after that. So pretty much what you would do is you'd have like a unlimited like time where you would keep on going forward until you bumped off that wall. And when you bump off that wall, you start like your next part of the program. Okay, so using an ultrasonic sensor, you can use it for 2 things. Stopping certain distances from objects, probably the most widely known one, and also to turn in the direction of an object if any part of the program is messed up. This part is more complicated because it requires a lot more programming specifics to it and like the color detection as well. So you would also need a color sensor to match up with this ultrasonic sensor. But the only problem is you can't do line following with this color sensor if you choose to use an ultrasonic sensor for this specific like task. And then what can you use gyro sensor for? So gyro sensors are probably the most intriguing and complicated sensor until you get the hang of it. So a gyro sensor pretty much removes all drift on a robot. So that means if you keep on going straight over a long period of time, you are more likely to go in a straight line with the gyro sensor than like swerve off a little bit. In addition, you can get more accurate turning with the gyro sensor to like the nearest 0.1 degrees. Well, it's going to be off by a little bit, but obviously it's going to be a lot closer than you just manually doing it or just putting in 90 degrees into your code and it doing it for you. So we'll go over the motors right now, and then we'll go over the other programming blocks in another video. So using the medium motor, below you can see a image of the medium motor. So pretty much there's at the left you have like a yellow brick or a yellow like start block. We call it a start block because obviously it starts the program. And so the first tab, right here with the like circle and like the hashtag in it, that is a selection for rotation, degrees, seconds, on or off. So with rotations, what you could do is you could pretty much do how many rotations do you want that motor to spin, how many degrees you want it to spin. Pretty much one rotation is just 360 degrees. Then seconds, you could do it for like 5 seconds, 10 seconds, however you want. And then on, it means it pretty much just keeps on going, and off, it means it just doesn't go. And then the top right section where it says letter A means what port it is plugged into. So there's going to be A, B, C, and D for motors. And then for your sensors and other stuff, it'll be 1, 2, 3, and 4, but we're going over motors. So in this one, we assume that most medium motors are plugged into A. And then we'll go into the other motors and where they're normally plugged into. And then also the second bar with like a speed motor or speed reading is like the speed of the medium motor. You can go from anywhere from negative 100 to 100, but if you choose a negative 100, you'll pretty much be going backwards. And then the next one to the right is the rotations, degrees, or seconds the medium motor is turning. And if it's on and off, you don't have to worry about that. And one additional thing is if your speed is negative and your rotations are degrees or seconds or whatever it is, or your seconds can't be negative, but your rotations and degrees are negative, you will move forward. Um, and if there are two opposite signs, one's negative and one's positive, it'll just go backwards. And then both positive will go forwards. Now using a large motor. So this is a selection for rotation degrees, seconds, on and off, same thing. And then on the top right, it's the same thing again with the port that the large motor is plugged into. And then on the bottom right, or bottom left, sorry, right next to the selection, you have the speed and you have the rotations. It's very similar to the medium motor. The only difference where you can see is that the medium motor has a different logo or like the motor shape itself, which is like on the left side of the programming block. It looks like it has like 4 or 5 holes. While here it looks more like a wheel, like tire or like a wheel holder. Yeah, and then this is a move steering block. A move steering block is pretty much if you want to move your robot with 2 motors and not just one. Back here in the large motor, you only turn 1 wheel, so it's mainly used for like turning. This move steering is mainly moved for like going forward, but you can also turn with it, depending on how you change like the direction of your turn, which we'll go over in the block. So the same things, the selection for rotations, degrees, seconds, on and off. And then on the top right, this time we have 2 motors because there's obviously 2 wheels that we're controlling. So in this set, we would have B and C. And then the first thing with an arrow is the direction of the turn. So this can go anywhere from negative 100 to 100. Negative 100 being a full left U-turn. Negative, or not negative, sorry. Positive 100 being a full right U-turn. And then your speed and then how many rotations, degrees, seconds, those are the exact same. And then move tank is very similar, except there's no turning element. You decide how you want to turn it. Or that was a bad way of putting it, but you pretty much change the speed on how you want to turn it. So the same thing, it's similar, the selection of rotation, degrees, seconds, on and off. And then the ports are plugged into large motors, because there's 2 of them. Then the one thing that's different here is the speed. So this time you have 2 speeds, one being of the left motor, one being of the right motor. And then pretty much if you have one speed larger than the other, it's going to turn depending on how much of an increase or decrease it is compared to the other motor. So that's it for what we have today. Come back next week for more videos on FLL tutoring lessons.